Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. Fired heaters, types and applications, part 2. Classification and types based on burner mounting and furnace draft, heater efficiency and heater selection. In this video course, you will learn classification and types of fired heaters based on burner arrangement and draft, fired heater efficiency and burner types, factors to be considered in fired heater selection. Please subscribe to the channel. By subscribing, you will motivate us to produce more knowledgeable video content for you. So subscribe now before you forget. Fired heaters. In the last video, we covered only part of the heater classification and types. We will cover the remaining part now and move on to other aspects. Classification by burner arrangement. Based on the burner arrangement, we can classify the furnace as wall mounted or floor mounted. Shown in this figure is an illustration of floor mounted type fired heater. The two burners shown are mounted on the floor. This is a photo of a floor mounted furnace. Several burners, depending on the furnace heat duty, are located on the floor of the furnace in rows. This figure is an illustration of wall-mounted type fired heater. The three burners shown are mounted on the wall, which are opposite to each other, for even heat distribution. Here again, the burners are decided by the heat duty. Multi-level wall-mounted burners are required for large heaters. Shown here is a photograph of a wall-mounted furnace in a refinery. This is a multi-level wall-mounted furnace design. Furnace classification by draft. Before we go into the classification based on draft, it is time to understand the draft and why is it required in fired heaters or furnaces. What is draft? Draft is a negative pressure created in the fuel-fired furnaces. Furnace draft is created when high temperature gases resulting from firing of fuels is discharged at a level higher than the furnace openings. This is commonly known as chimney effect. The below mentioned correlation can be used to calculate the draft in inches of water column generated in the heater. Draft equals 0.52 H times P atmosphere times 1 by T ambient minus 1 by T flue gas. Where H is a firebox height in feet, P atmosphere is atmospheric pressure in psia, T amp is the ambient temperature in degree Rankine, Tfg is the T flue gas temperature in degree Rankine. The draft in a furnace that operates at a fixed temperature changes with heat input rate or mass flow of flue gases moving through the stack. Why is draft required in a furnace? Slight negative pressure is required while operating the fired heater so that combustion products do not escape into the surrounding area through the furnace openings. If pressure is positive inside the furnace, when the opening the inspection window and the doors, hot flue gases will come out and hit your face, making inspection not possible. Having understood the draft and the need for the same in the fired heaters, let us move on to the classification of fired heater based on the draft design. Furnaces by draft design can be classified into natural draft, forced draft, induced draft, and balanced draft. The induced draft is a heater in which chimney effect is used. The gases inside the furnace are less dense and will rise. This creates a vacuum that draws air into the furnace. The height of the chimney is an important design parameter for natural draft to work. The draft produced by the chimney effect or natural draft is affected by atmospheric conditions. The limitation is that the natural draft system would not be able to remove large volumes of flue gases with a chimney of reasonable height. Induced draft fired heater shown in this figure is an induced draft type fired heater. It is a heater which uses a fan to remove the hot flue gases and creates negative pressure or draft inside the furnace, which induces the combustion air without a forced draft fan. The action of induced draft is similar to the natural draft, except that it uses a mechanical fan to force the flue gases to exit the stack. The draft produced is independent of the temperature of the hot flue gases. Hence, flue gases temperature can be reduced, permitting use of air preheaters in induced draft system. The total draft produced is sum of the draft produced by the induced draft fan and the stack or the chimney. Forced draft fired heater shown in this figure is a forced draft heater. It is a heater for which the combustion air is supplied by a fan. The fan or blower is installed at the bottom as shown in this figure. The air is forced through the burner to the combustion chamber, the convection section, and the stack. A stack is required, but its purpose is different. The purpose is to discharge the flue gases at a reasonable height to reduce environmental effect. The last type of fired heater in this category is a balanced draft fired heater. Balanced draft type heater is illustrated in this figure. It is a heater which uses a forced draft fan to supply combustion air and induced draft fan to remove the hot flue gases. The FT fan supplies the combustion air and the ID fan sucks in the flue gas after heat recovery and causes it to exit the stack. It is desirable to use a combination of forced draft and induced draft in large heaters. In forced draft furnaces, the furnace is at slight positive pressure. It makes it unsafe to open the furnace inspection windows for visual inspection, which is an operational necessity. Because when you open the windows, due to the pressure being higher than atmospheric pressure, the hot flue gases will hit your face, as discussed earlier. When only induced draft is used, during opening of the inspection windows, cold air will leak into the furnace and increasing the load on the induced fan. Hence, for large heaters incorporating air preheaters to enhance efficiency, the balanced draft is the preferred option. Burner selection and efficiency. Process burners are unique for each application. Traditional premix burners on a process heater premix the fuel with the primary air, which is inspired to the burner by the fuel gas flow. The pressure of the fuel gas supply is important since a low gas pressure degrades its performance. The primary air flow should be maximized without lifting the flame of the burner. Most of the air as primary air is delivered to the burner along with the fuel. Secondary air is introduced and adjusted with the registers. A correctly set burner with good air and fuel mixing produces maximum flame temperature in a compact conical flame. Too much or too little secondary air gives poor combustion. A minimum excess air level is required for complete combustion, but too much excess air reduces flame temperature and drops efficiency. This figure illustrates a typical burner used in the fired heater, showing the pre-mixed chamber, where the fuel is mixed with the primary air with the help of a primary air register. The burner port for adjusting the secondary air is also shown. The high temperature in the flame and radiant section, together with combustion turbulence at the burners, causes reaction of oxygen with nitrogen, forming nitric oxide NO and nitrogen oxide NO2, which is undesirable for the environment. Low excess air firing is the simplest way to reduce the NOx formation and improve the efficiency. The new environmental norms require low NOx burner design. Steam automation. Certain burners need another agent to assist in the mixing of fuel and air for combustion. Steam automation is the concept followed in such burners. Steam automation is used in oil burners to assist the mixing of oil and air to promote full combustion. With steam injection, the oil is reduced to fine spray that mixes with air and burn easily. This leads to short and intense flame. The factors to be considered in the burner selections are heater geometry, fuel type, heater duty requirements, environmental emission standards. Operational control of fired heaters. The operational aspect of fired heater is important from the process efficiency, safety, and environmental point of view. The furnace is a very complex process equipment package with high energy consumption. Hence, its performance needs to be monitored and controlled by key measured and controlled variables. The important parameters usually controlled in the fired heater are depicted in this figure shown. The parameters to be monitored and controlled are feed flow and inlet temperature, coil gas outlet temperature, fuel gas pressure, and excess air. How to select the best fired heater? The selection of fired heater takes into account several factors for optimizing the performance at reasonable cost. The factors considered include type of fuel available, nature of applications, heat integration opportunities for steam and process heating, capital and operating cost. Fired heater thermal efficiency. Efficiency is expressed as total heat absorbed divided by the total heat input. Total heat absorbed is total heat input minus stack losses minus radiation losses. Presented in this table is a typical fired heater efficiency. The fired heater design may be of three types: radiant only, radiant plus convection section, radiant plus convection section plus air preheating. The efficiency of radiant only design is typically 50 to 60%. Radiant and convection type design will have an efficiency of 80 to 85%. Radiant plus convection plus air preheat will have an efficiency of 90 to 93%. Radiant only type design is used for small heat duties, usually of natural draft type. Applications include startup heaters for preheating of process systems before the feed cutting. Radiant plus convection design, most commonly used in refineries and petrochemical plants. The draft type depends on the application. For heating up the process feed to reactors such as charge heaters, the heater may be of natural draft or induced draft. When used as a reactor or cracker, balanced draft is usually the choice. Radiant plus convection plus air preheating. In the system, a air preheater is included to enhance heat recovery further from the flue gas, thereby improving the thermal efficiency. Since system resistance are repeatedly higher, these heaters are of balanced type. Increasing energy costs and need to enhance thermal efficiency, the latest technology make use of integrated fired heater package. The design consists of radiant section, convection section, air preheat plus steam generation. This figure is an illustration of an integrated cracker furnace incorporating radiant plus convection plus steam generation plus process steam superheating, an integrated package. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.